Today we will be solving quotient rule with chain rule. In some equations we might encounter using both quotient rule and chain rule. To remind you, quotient rule is whenever we have a numerator and a denominator, where we denoted them as u over v. Their derivative, f prime of x, would be u prime v minus v prime u all over v squared. That's for the quotient rule. For the chain rule, you would have a function denoted by u to the power of n being any natural number. Its derivative would be f prime of x is the power itself, the derivative of the function, and then the function to the power of n minus 1. Let's do some small examples of quotient rule and chain rule before we move on to both of them combined. Let's say we have f of x is 3x minus 1 over x plus 2, and we need to find the derivative of that. To do that, we need to take the numerator as u and the denominator as v. And now we find u and u prime and v and v prime. So our u is 3x minus 1 and our v is x plus 2. The derivative of 3x minus 1 is 3, and the derivative of x plus 2 is 1, because the derivative of x is 1, and the derivative of 2 is 0, because the derivative of any constant is 0. And now we just apply u prime v minus v prime u over v squared. So we'll have u prime v minus v prime u all over v squared. And of course, since we can distribute the numerator, we'll need to distribute it in that case. So 3x plus 6 minus negative 1 times 3x is negative 3x, and negative 1 times negative 1 is positive 1 over x plus 2 squared. And our final answer will be 3x and negative 3x cancel out. So we'll have 7 over x plus 2 squared. This is for the quotient rule. Now for the chain rule, as we said, is whenever we have a function to the power of something. So for instance, 3x minus 1 power 4. First, we need to identify our u and our n. N is always the power. So our n here is 4, and our u here is 3x minus 1. U prime is 3, because the derivative of 3x is 3, and the derivative of negative 1 is 0, because the derivative of a constant is always 0. And now we apply f prime of x is n u prime u n minus 1, and we just replace. F prime of x will be n is 4, u prime is 3, and u n minus 1, so we'll have 3x minus 1 power 4 minus 1. 4 multiplied by 3 is 12. 3x minus 1 power 4 minus 1 is 3, and this will be our final answer. Now, since we did a small revision about quotient rule and chain rule, let's now do the derivative of the function we have here. First, since we have a numerator over denominator, we need to take the numerator as u and the denominator as v. So u is x squared plus 1 power 5, and v is x minus 1. Now we need to find u prime and v prime. To find the derivative of u, we have a function to the power of something. So u power n. Find the derivative of it, it is n u prime u n minus 1. So our n is 5, our u is x squared plus 1, and we need to find u prime. The derivative of x squared is 2x, and the derivative of 1 is 0. And now we just replace. So n, which is 5, u prime, which is 2x, multiplied by x squared plus 1 to the power of 5 minus 1, which is 4. And now we can simplify that and multiply 5 by 2x, so 10x into x squared plus 1 power 4. Now v prime derivative of x is 1 and derivative of negative 1 is 0 because it is a constant. This is our u, this is our v, this is our u prime, and this is our v prime. And now we just apply u prime v minus v prime u over v squared. So our f prime of x will be u prime, which is 10x into x squared plus 1 over 4 times v minus v prime times u all over v squared. This will be our final answer. Let's do another example. Let's say we had f of x is x minus 1 over x plus 2 all to the power of 3. Here we'll need to start by the chain rule and then do the quotient rule. Whereas in the previous example, we first did the chain rule to find u prime, and then we did the quotient rule to find f prime of x. Here, as I mentioned, we start by implementing the chain rule, by taking the function to be u and the power to be n. So now, our n is 3. Our u is x minus 1 over x plus 2. Now we need to find u prime. To find u prime, we need to take the numerator as u and the denominator as v. U equal, v equal, u prime equal, and v prime equal. U is x minus 1 and v is x plus 2. The derivative of x minus 1 is simply 1. And the derivative of x plus 2 is also simply 1. The derivative of x is 1 and the derivative of 2 is 0 since it is a constant. And now we do u prime v minus v prime u over v squared. So u prime v minus v prime u all over v squared. And we can expand the numerator. So 1 times x is x, 1 times 2 is 2, negative 1 times x is negative 1, and negative 1 times negative 1 is positive 1, all over x plus 2 all squared. So our final answer for u prime will be 3 over x plus 2 all squared. That will be our u prime. So now we have our u, which is here. We have our u prime, which is here. And we have our n. And now we apply prime of x is n u prime u n minus 1. So our n is 3. Our u prime is 3 over x plus 2 all squared. And now we multiply by u to the power of n minus 1. So 3 minus 1, which is 2. And we can expand and multiply 3 times 3. So we'll have 9 over x plus 2 all squared multiplied by x minus 1 over x plus 2 all squared. And that will be our final answer. Let's do one more example using radicals. Let's say f of x is radical x squared minus 1 over x plus 3. Before, we had the power to be 3, but here we have a radical, so we need to find the power ourselves. We need to remember that radical a means a to the power of half. A radical is always power half. But if we had a cubic root, then it will be a to the power of 1 over 3. The general rule is whenever you have a power m and radical of n, the final answer will be a m over n. This is the general rule that you'll always use. So since we mentioned that, we can write f of x now as x squared minus 1 over x plus 3 power half. Half will be our n, and x squared minus 1 over x plus 3 will be our u. Now, we have u as x squared minus 1 over x plus 3. We need to find u prime. To be able to find that, we'll take the numerator as u and the denominator as v. And we solve u equal, v equal, u prime equal, and v prime equal. Our u is, as you mentioned, x squared minus 1, and v is x plus 3. The derivative of x squared minus 1 is 2x. The derivative of x squared is 2x, and the derivative of negative 1 is 0 since it is a constant. The derivative of x plus 3 is simply 1. The derivative of x is 1, and the derivative of 3 is 0. And now we just apply u prime v minus v prime u all over v squared. So we'll have u prime times v minus v prime times u all over v squared. And now, of course, we can expand the numerator. 2x multiplied by x will give us 2x squared. 2x multiplied by 3 will give us 6x. Negative 1 times x squared will give us negative x squared. And negative 1 times negative 1 will give us positive 1. And now we combine like terms. So 2x squared minus x squared will give us x squared plus 6x plus 1 over x plus 3 whole squared. Now, this is our u prime, and our u we have it up, which is x squared minus 1 over x plus 3. And we have our n to be half. Now we just apply the rule, which tells us f prime of x is n u prime u n minus 1. So f prime of x will be n, which is half, u prime, which is x squared plus 6x plus 1 over x plus 3 squared multiplied by u power n minus 1. So x squared minus 1 over x plus 3 to the power of half minus 1, which is negative half. Now you can either keep it like that or use the rule of a to the negative m is 1 over a power m, which can give us 1 over 2 x squared plus 6x plus 1 over x plus 3 whole squared over 2 multiplied by x squared minus 1 over x plus 3 to the power of half. And now, as we did before, we converted the radical a to a power half. We moved from radical to power. Now we can move from power to radical by simply shifting the half back to a radical. So we'll have x squared plus 6x plus 1 over x plus 3 whole squared multiplied by 2 radical x squared minus 1 over x plus 3.